Hello everyone, welcome back or welcome to my channel. Today's video is we have here a Math Olympiad question. 8 to the power of x plus 2 to the power of x equals 130. And in here we'll be looking for all the real values of x. So how do we solve this exponential equation? So first, let's convert 8 to the power of x to base 2, since this one is base 2. So we have 2 cubed. 2 cubed is 8, so exponent x plus 2 to the x. And we're transposing 130 to the left side. So we have negative 130 equals 0. And here, we can write this the same way as 2 to the power of x raised to the third power plus 2 to the x minus 130 equals 0. So from here, we're introducing a new variable to represent 2 to the power of x. So we have u is equal to 2 to the power of x. So let's substitute this to our equation. So we have u cubed plus u minus 130 equals 0. So here we have a cubic equation. This cubic equation can be written the same way as u cubed plus 0 u squared plus u minus 130 equals 0. So from here, let's focus on the first term of the cubic equation. The coefficient is 1. So let's designate that as q. And let's focus on the constant 130 as p. And we're taking all the factors of 130. So here we have 1, 2, 5, 10, 13, and 26. So from here, we're trying to find the possible values of u by dividing p with q. So we have p divided by q. There will be all the possible values in terms of positive, negative. So we have 1 divided by 1 is 1. 2 divided by 1 is 2. And so 5, then 10, 13, and 26. And so to find the value of u, we have to substitute these possible values of u over here. Alright, so substituting 1, looking at our constant, it's 130, that's a big number. And the coefficients over here are 1, and here is 0. So obviously 1 and 2 are out of the way. So we ruled out 1 and 2, or positive, negative 1 and 2 as the value of u over here, since this is a big number, 130. How about trying 5? Substitute 5 to the equation. So we have 5 cubed plus, since this is 0, so we have 0 right there, and we have u right there. So 5 again minus 130. So would this be equal to 0? We have 5 cubed, that's 125, plus 5 minus 130. So is this equal to 0? So we have here 125 plus 5 is 130 minus 130. So this is equal to 0. This simply means that one of the values of u is 5. So u is equal to 5. So now let's find the factor of the cubic equation by using this value of u. So we'll be using synthetic division. So we have here 5. And all the coefficients of the terms of the cubic equation from here. So we have 1, then 0, then 1 again, then minus 130. So we have here, bring down 1, and we multiply 5 times 1 is 5, and we add these up. So 5 plus 0 is 5. 5 times 5, that's 25. Plus 1 is 26. Times 5 is positive 130. So 130 minus 130 is 0. So remainder 0. So we have now 1 as coefficient of u squared. From u cubed down 1 degree. So this is now 1u squared, then plus 5u plus 26. So this is the other factor of the cubic equation. Let's equate this to 0. So first, let's find the discriminant. The discriminant is equal to b squared minus 4ac. And here, b is 5, c is 26, and a, by the way, is 1. So a is 1. So the discriminant b squared, that's 25, minus 4 times a is 1, and c is 26. This is equal to 25 minus 4 times 26. That is 104. So the discriminant is equal to 25 minus 104. That is negatives 79. So this is less than 0. What does it mean by this? So this means that we have no real solution. No real solution to this. So we don't have real values of u on this quadratic equation. So the value of u that we found earlier was 5. So that is from here. So we have here u is equal to 5. And since u is just a substituted variable, that is equal to 2 to the power of x. So we have 2 to the power of x is equal to 5. Solving for the value of x, so we can use logarithm. So we can take the logarithm of both sides. So we have log 2 to the power of x is equal to log of 5. So from here we can take down the exponent as a coefficient from logarithm power rule. So we have log of a exponent b is equal to, we can take down the exponent to the front as a coefficient. So we have b times log of a. So we use that on here. So we're putting down x to the front as a coefficient. So we have x times log of 2 equals log of 5. Solving for x, divide both sides with log of 2. So we have here x is equal to log of 5 divided by log of 2. Or this can be written the same way also as log of 5 base 2. And so from here, for the sake of checking our answer, we need to find the numerical value of x. So x, by using our calculator, it is approximately equal to 2.3219. And so now let's check our answer. So we have the original equation and the value of x approximately equal to 2.3219. So first term we have 8 to the power of x, that is power of 8 to the power of 2.3219, plus 2 to the power of x, 2 to the power of 2.3219, and would this be equal to 130? So the first term, 8 to the power of 2.3219, is equivalent to 124.99. Then plus 2 to the power of 2.3219. This is approximately equal to 4.99. And if we add this up, 124.99 plus 4.99, this is approximately 130. And this is equal to 130. So this confirms that the value of x that we found is correct. So we have here the exact value of x, log of 5 base 2, x in numerical value is approximately equal to 2.3219. That's our final answer.